The hair surface has more protons than electrons, while the balloon surface has more electrons than protons. The correct answer in our previous question is this. The hair is positively charged because it has more protons, while the balloon has more negatively charged particles. So the charge is negative. Again, it is because the balloon has more electrons. Now, what are some real-life examples of static electricity that you know? Static electricity has several uses and applications like printing, painting, and dusting. Now, do you know that lightning exhibits static electricity? Lightning is a very powerful and dangerous example of static electricity in nature. It is being generated due to friction between ice crystals and graupel or snow pellets in a storm cloud. The lightning bolt that strikes the Earth's surface is a discharge of electricity due to overflowing static electricity buildup in storm clouds. This instantaneous discharge carries as much as 1 gigajoules of energy. Now, how much is that in terms of joules? 1 gigajoules of energy is equivalent to 1 billion joules. That's a lot of energy. Now, let's talk about current electricity. This is a familiar kind of electricity to us because we use this in our electrical devices at home. Current electricity has measurable properties that we need to study to understand how current electricity works. The first property is the electric current. We will talk about the other properties, voltage, and resistance in our next session. An electric current, or simply called current, is a stream of charged particles such as electrons that move through an electric conductor. The SI unit for current is ampere, which is described as the flow of electric charge across a surface at the rate of 1 coulomb per second. The name ampere is used in honor of the French physicist André-Marie Ampère, who is known as the father of electromagnetism. Current can be measured using a device called the ammeter. Now, how can we describe the flow of electric current in a system? Recall that electric charge is being carried by atoms that contain protons and electrons. In an electro-conductive material, these charged particles move depending on the nature of the material. If the material is a metal, positively charged atomic nuclei are held in a fixed position, while negatively charged electrons are free to move about in the metal. If the material is a semiconductor like silicon and germanium, the charge carriers can either be positive or negative. If the material is an electrolyte, charge carriers can either be both positive and negative particles. A flow of positive charges gives the same electric current as of the flow of negative charges in the opposite direction. Since current can be the flow of either positive charges or negative charges, or even both, a convention is needed for the direction of the current that is independent of the type of charge carriers. The direction of conventional current is defined as the direction in which positive charges flow. On the other hand, negatively charged carriers such as electrons flow in the opposite direction of the conventional current flow in an electrical circuit. There are two types of electric current: direct current and alternating current. Direct current has a single flow of electric charge. Direct current is usually found in batteries and solar cells. On the other hand, the alternating current reverses its flow of electric charge many times a second at regular intervals. Alternating current is being utilized by electrical power plants to generate high amounts of electrical power and to enable the conversion of electrical voltage levels using transformers. Most wall sockets at home uses alternating current. Now that you have learned a lot for today's session, let us recap some of the most important pointers to remember. First, electricity is a physical phenomenon that is caused by the behavior of electrical charges in a system. Second, an electrical charge is a physical property of an object that is affected by the number of protons and electrons. Third, static electricity is a stationary electric charge, while current electricity is a flowing electric charge. Fourth, the electric force is directly proportional with the electric charge and inversely proportional to the distance between the two objects. Let us now answer some questions that our students sent us. So, yan. Thank you. Let me look first for some questions that we can answer today. And I think this would do. Okay, let me read first the question. Good morning, sir. Can we identify the direction of the current flow? If yes, how can we identify it? Okay, thank you for that question. So let me answer it. The answer is, it is difficult for us to identify the direction of the electric current flow because there are several factors that we need to consider. So some of those are one, the type of electroconductor, also the type of current, and we also need to consider the type of electric charge that flows in the conductor. And there are several other factors aside from that. Now, this is the reason why we are using convention. So a while ago, I said that there are two types of convention. So one is the conventional current flow, which describes the flow of positive charges. And we also have the electron current flow, which describes the flow of negative charges. Okay? So I hope I have answered your question. Let me read now another question that we can answer. Okay, I think this would do. Let me read it for you class. Good morning po, sir. Which type of electric current is more dangerous? AC or DC? Thank you po, sir. Okay, thank you also for that question. So the correct answer for that question is actually electrical hazard has little to do with the type of current, whether it is AC or DC. Because an electrical hazard is primarily caused by high electric voltage. We will learn more about electric voltage in our next session. Now, what's more important is that both AC and DC can potentially bring hazards if it is not handled properly. So, always practice safety measures in handling electrical appliances. Now, if there are other questions that you want to ask, feel free to type in your questions in the comment section and I will do my best to answer your questions. That's it for our session today. See you next week for another episode of Grade 8 Science Valenzuela Live. Stay safe and have a great day.